Good morning students. Hopefully everyone is fine. Today we are going to study about chapter 10, Refraction and Dispersion of Light. Now we will understand about refraction of light. The phenomena of refraction may be regarded as the observation of change in direction or bending of light when it passes from one transparent medium to another. Refraction is basically due to change in speed of light in two different transparent media. When light passes from one transparent medium into another, it may either slow down or start moving faster. For a given pair of medium, the medium in which speed of light is less is called the optical denser medium, and the medium in which speed of light is more is called the optically rare medium. Main cause of the refraction: change in the speed of light when it goes from one optical medium to another optical medium. The speed of light is different in different media. In vacuum, light propagates at a speed of 3 × 10⁸ meter per second. When it enters any other transparent medium, its speed decreases. It is this change in speed of light that causes a light ray to bend when it goes from one medium to another. Thus, bending of light rays is basically due to a change in the speed of light when it goes from one medium to another. Let us understand about some activities. Firstly, we will dip a straw in a glass of water at about 45 degrees to the surface of the glass. Examine the appearance of the straw when viewed at an angle of the surface of the glass. You will observe that the straw appears bent near the surface of the water. You can perform another activity regarding to refraction of light. You will take a glass of water, look at a person whose face is close behind the glass of water. Observe the shape of her or his face. Both activities show the refraction of light. Next topic is refractive index and optical density. The refractive index of a given medium is a dimensionless number that determines the extent of change in direction of a ray of light as it goes from free space into that medium. The refractive index or absolute refractive index of a transparent medium is the ratio of the speed of the light in vacuum to its speed in that medium. The relative refractive index of a medium with respect to another medium equals the ratio of the speed of the light in medium first to its speed of light in medium second. Refractive index or absolute refractive index of a medium denoted by μm is defined as speed of light in vacuum upon speed of light in the given medium. Some assignment question: define refraction. Second, mention the cause of refraction. Third, define refractive index and optical density. Write relation between the both. Next question, write speed of light in water, glass and air. Thank you to all my students. Good morning student. Today we are going to study about refraction and dispersion of light. Now we will discuss about rules of refraction. First, a ray of light bends toward the normal when it goes from an optical rare medium to an optical denser medium. And second rule, a ray of light bends away from the normal when it goes from an optical denser medium to an optical rare medium. You can see in the picture, when moving from low to high refractive index, light bends toward the normal. You can take the example from air to the glass. And when moving from higher to low refractive index, light bends away from the normal, from glass to air. Now understand the rule of refraction by this activity. Firstly, pencil partially is immersed in water. The rays of light starting from, say, the tip of the pencil bend away from normal as they move from water to air. Therefore, these rays appear to be coming from a point that lies above the actual position of the tip of the pencil. The same is true for all other points of the pencil under water. The part of the pencil under water thus appear bent with respect to its parts above the water. Now you can see in the picture. In the first picture, a pond appears less deep than it actually is. Second, A coin at the bottom of a cup becomes visible after some water is poured into the cup. When a coin put in an empty cup not visible before becomes visible after some water is poured into the cup. In both diagram, we can see that it is the bending of light rays away from normal as they move from an optical denser medium to an optical rare medium that is responsible for our observations. If the light ray enter another medium perpendicular to boundary, the ray does not bend. You can see in the picture. We can understand refraction of light by glass slab. In case of a rectangular glass slab, refraction takes place at its air glass interface as well as its glass air interface. The emergent ray is parallel to the direction of the incident ray but is slightly displaced. You can see in the picture the initial ray PQ falling on the glass slab is called as incident ray. The path of the ray MN within the glass slab is known as the refracted ray. The final ray RS coming out of the glass slab is known as the emergent ray. The angle between the incident ray and the normal of the point of the incidence M is known as the angle of incidence I. The angle between the refracted ray Mn and the normal at the point of incidence is known as the angle of refraction, angle R. The angle R dash and angle E are similarly the angle of incidence and refraction respectively at the face CD of the glass slab. It turns out angle E equal to the angle incidence. Do some assignment question. First question, explain roles of refraction with the help of diagram. Second question, give reason. A pond appears shallower than it actually is. A pencil appears bent dipped in a glass of water. And third question, explain refraction through glass slab with the help of diagram. Thank you to all my students. Good morning student. Today we are discuss about the third part of refraction and dispersion of light. Let us understand about dispersion of white light by glass prism. A prism is a piece of a transparent metal bounded by two plane surfaces inclined at an angle. Not only deviate or bend an incident ray towards its base but also split white light into 7 colors. Now understand about cause of dispersion. The dispersion of white light occurs because colors of white light travel at different speed through the glass prism. The amount of refraction depends on the speed of colored light in the glass. The different colors travel at the different speed. They are refracted by different angle on passing through the glass prism. So, when white light consisting of 7 colors falls on a glass prism, each color in it refracted by a different angles, with the result that 7 colors spread out to form a spectrum. It means dispersion of light, the splitting up of the white light into 7 colors on passing through a transparent device like a glass prism. The dispersion of white light occurs because the different constant color of white light propagate at different speed through the glass prism. Which component deviate minimum? The red color has the maximum speed in the prism, so the red color is deviate the minimum. Ray of violet color bends the maximum. This results in white light getting split into its 7 constituent colors from red to violet. Rainbow observed in the sky is a natural phenomenon associated with dispersion of sunlight by the raindrop suspended in the air. Now do some assignment question. First one is define dispersion. Second, which light bend maximum and minimum through prism toward base? Give reason. Third, mention one of the dispersion through nature. Thank you to all my students. Good morning student. Today we are going to study about spherical lenses in this part. Lens is a portion of a transparent refracting medium bounded by two surfaces. When both or one of these surfaces is spherical, the lens is known as spherical lens. Spherical lenses are either convex, thicker in the middle and thinner at the edges, or diverging concave, thinner in the middle and thicker at the edges. Now understand about the lens related terms. First, center of curvature. The center of the two spheres of which the two surfaces of the given lens are apart. Term radii of curvature. You can see in the picture the radii of the two spheres of which the lens surface are a part of principal axis. The line joining the center of curvature of the two surfaces of a lens is called principal axis. Term optical center, the special point on the principal axis of a lens through which light passes without undergoing any bending or deviation. Next term is principal focus or focal length, a point on the principal axis where all the rays incident parallel to the principal axis actually meet in the case of convex lens or appear to meet in the case of concave lens after refraction through the given lens. Focal length means the distance between the optical center and principal focus of the lens. Topic is three spatial rays for lenses. First, an incident ray parallel to the principal axis passes through the principal focus of the lens. Second, an incident ray passing through the optical center of the lens goes undivided from the lens. You can see in the picture second. In picture third, you can observe that an incident ray passing through the principal focus of the lens or directed toward it become parallel to the principal axis after refraction from the lens. Do some assignment question. Define the following terms: center of curvature, radii of curvature, principal axis, optical center, principal focus. Second question, draw diagrams of three spatial types of rays for lenses. Thank you to all my students.